In this video, I'm going to show you how to do Edexcel A-Level Maths from June 2019, Paper 1, Question 14. My name is Sunil Tanner. I'm a tutor and author. I'm available for one-to-one tuition. I live in Buckinghamshire, England. The curve C in the standard Cartesian plane is defined by the equation x equals 4 sine of 2y, where y is between minus pi over 4 and plus pi over 4. Curve C passes through the origin O. Find the value of dy dx at the origin. Okay, so we have an expression for x in terms of y rather than y in terms of x. So it's a little bit hard to find dy dx in the normal way. So instead what we do is we find dx dy. So dx dy is equal to the derivative of this with respect to y, which will be 4 times the derivative of sine 2y is 2 cos 2y. So expanding out the brackets, we get 8 cos 2y. And then if we have dx dy, dy dx will be 1 over that. So dy dx is 1 over 8 cos 2y. Now at the origin, we know that x and y are 0. So at O, y equals 0, which tells us dy dx is 1 over 8 times cos of 0, which is 1/8. And that completes part A of the question. Part B of the question, part 1. It says use the small angle approximation for sine 2y to find an equation linking x and y for points close to the origin. So we know that sine 2y will be approximately equal to 2y if y is small. So that tells us now x will be equal to 4 times 2y, or approximately equal to 4 times 2y, again if y is small, which tells us x is approximately equal to 8y if y is small. Okay, and then we have part B2 of the equation. So if we slightly rearrange this, x is approximately equal to 8y, we will see that y is approximately equal to 1/8 of x, which tells us that the gradient at the origin, or close to the origin, is 1/8, which of course is the value we found in part A of the question. So gradient at origin, explaining the relationship, is 1/8 as found in A. Okay, so then we have part C of the question. Show that for all points x, y lying on C, dy dx is 1 over a times the square root of b minus x squared, where a and b are constants to be found. Okay, so we're going to use two identities to find this. The first thing is we already have from the previous part of the question that dy dx is equal to 1 over 8 cos 2y. Now we have our trig identity for cos of any angle. For example, cos squared theta plus sine squared theta is always equal to 1, so we could use an identity triple equal sign. So here, in this particular case, we would have that cos squared, cos of 2y, let's write cos squared of 2y is equal to 1 minus sine squared of 2y. Now we also know that sine of 2y, using the original equation, is equal to x over 4. So this tells us that cos of 2y is equal to the square root of 1 minus x over 4 squared. So substituting that in the equation, we get dy dx is equal to 1 over 8 times the square root of 1 minus x over 4 squared. Now, what we can do is expand this out and we'll get x squared over 16. And if we write the 1 as 16 over 16, we will have dy dx is equal to 1 8 square root of 16 over 16 minus x squared over 16. And we can take this bottom 16, square root of 16, out of the square root. So that will be 1 over 8 divided by the square root of 16 times the square root of 16 minus x squared. Now the square root of 16 is 4 and 8 divided by 4 is 2. So the final answer is 1 over 2 times the square root of 16 minus x squared. So in this case, A is 2, B is 16. And that completes question 14.